Good day. So I'm going to show you how to prove that this angle is equals to this angle, or how to prove the chord theorem. So the question can say prove that BAC is equals to CBF, right? Or they can say prove the theorem that says that BAC is equals to CBF, right? Which is the chord theorem. So what do you do here? So we have to prove that this angle is equal to this. So the first thing you're going to do is you're going to say construct, let's call this center O, right? Let's just say it was O in the question. So you will say construct line OB and line OC. So construct OB and OC, so that's what you'll construct. And just before I continue, don't forget to like the video and subscribe to my channel if you want to see me solving more things. So you tell them construct OB and OC, right? Because those lines were not there, so you have to tell them construct those. And then what you're gonna do is you will say let angle BAC be equals to X, right? So you will tell them that let angle BAC be equals to X. So how is calling this X going to help you? So this is how it's going to help you. You're going to use the theorem that states that angle at the center is twice angle at the circumference. So if this be X, then this is going to be 2X. So then you will tell them that angle BOC is equals to 2X. And you know why? Because angles at the center is twice angles at the circumference. I'm not really going to write that. You know how to write it. I assume you know how to write the reason. So angle at the center is twice angle at the circumference. Now what we need to find is this angle. So how are we going to find it? Then we'll use the theorem that states that this is a radius, this is a radius, so they're both equal. So this is radii, right? So we'll tell them that OB is equals to OC, radii. Now, how is that going to help us? It's going to help us to realize that this is an isosceles triangle. Whenever we have as an isosceles triangle, it means this angle is equals to that angle, right? So if I draw it fully so that you can see the picture, this is equals to this, so therefore these two angles must be equal. Whenever we have an isosceles triangle, the base angles of the isosceles triangle will always be equal. So for instance, if the triangles like this and this are equals to this, then this would be the base angles of the triangle, they would be equal. So it means that angle OBF is equals to angle OCB, right? Just naming these two angles, this angle and this angle. They're equal because it's base angles of isosceles triangle. That's what you write there. So these two are equal. So the fact that these two are radii, it means that this is an isosceles triangle because we have two sides of the triangle being equal. So therefore the base angles would have to be equal. So now we can find them. So in an isosceles triangle, whenever we have one angle, we actually have all angles. So why am I saying so? Because we have this angle, right? So now it's going to be easier to find the rest because these two angles are equal. So what we're going to say is when we add this stuff, when we add angle OBF and angle OCB and that 2x, they will all be equals to 180 because of sum of angles in a triangle. So we add these three, they'll be equals to 180, right? And then now since these two are equal, in the next step we'll just say, and what we want to find is angle OBC. So angle OBC. So we want to find angle OBC. So yeah, I wrote OCB, but it's the same. So I'm going to write this as angle OBC as well, plus angle OBC. Why am I writing it twice? I just replaced this with this because they're equal. So plus 2x equals to 180. Then you have to tell them how you did it. We did it because these two are equal. We have to tell them that OBF is equals to OCB. We just have to tell them that. So now we can add, so they're like terms now. So this plus this will be 2OBC plus 2x is equals to 180. So when you take this to the other side, it means 2OBC is equals to 180 minus 2x. And then now I have to divide both sides by 2 so that I can be left with OBC only. Okay, just have to put a cap wherever we put angles. So when I divide both sides, then I will have OBC is equals to, when we divide this by 2, this is just 90 minus x. So I got this as 90 minus x, and we're almost done. So this part is 90 minus x. And then another important theory you have to use is the fact that, notice, this is a radius and this is a tangent. So a radius is always perpendicular to the tangent. So what does it mean? It means this angle, the outer angle, angle CBF, right? So now we're going to have to tell them that angle CBF plus angle OBC, the one we found, is equals to 90, right? Then you have to tell them that the radius, so we say the radius is perpendicular, so we have to tell them the radius is perpendicular to the tangent, right? That's why we're saying these two angles add up to 90, because the radius is perpendicular to the tangent, right? So this angle that we're looking for plus that angle is equals to 90. But now we know the size of this angle. We found it before, right? We found it was 90 minus x. Okay, I erased it. 90 minus x. So it means angle CBF, which is this outer angle CBF, right? Plus 90 minus x. That's what I found. I found it as 90 minus x, which is what I wrote here, right? Is equals to 90. Then when we take this to the other side, we'll end up having, so let's take this to the other side. So now we have angle CBF, okay, not CPF, but CBF is equals to 90 minus 90 plus x. So I took this to the other side. So now this 90 minus 90 just cancels and we're left with x. So it means angle CBF is equals to x. So this angle is equals to x. And just take a look at it. We named this x and this is also x. So they're equal, right? So this is also x. And we have answered it. They said prove that angle ABC, angle BAC is equals to CBF. So they said prove that this angle is equals to this angle. But we've seen that this angle is x. We named it x. And using the theorem of angle at the center is twice angle at the circumference, we found this angle. And in turn, finding this angle, because this is an isosceles triangle, it helped us find those two angles, right? This is 90 minus x. That one is also 90 minus x, but we don't need to name that one because it's not going to help us. What's going to help us is this one. So we found this as 90 minus x. Then we needed to find the outer angle. And how did we find it? By using the theorem that radius is perpendicular to the tangent and knowing that both of them will add up to 90. So using that, we found out that this is also x. And we're done. This is x, this is x. So therefore we can now say therefore angle BAC is equals to CBF. And why are they equal? Because both are equals to x, and we're done. We have proven it. And any questions you've got, and if you don't understand anything, please comment on the section below. If you want me to make a certain video, comment below and I will make that.